First of all, welcome to the Big Android BBQ. This is my first Big Android BBQ. How about you guys? Have you been before, or are you guys all first-timers too? How is it so far? Keynote sounds like it was fun, right? So I'm looking forward to the food later too. My name is Lawrence Moroney. I work for Google as a developer advocate. I specialize in a technology called Google Play Services. And my role is generally speaking, writing, working with developers around using Google Play Services and some of the related technologies around Google Play Services in your application. And one of the related technologies is our Google Cloud Messaging. And today I just wanted to talk a bit about messaging, talk about the type of things that you can do with Google Cloud Messaging. And most of the session, I'm actually going to be building a very simple Google Cloud Messaging based app on stage with you guys. And it's actually going to have a live server where messages can be sent to my phone, and the URL will be exposed, and people tell me it's a mistake to do that, but I assume you're all going to behave. So without further ado, Google Cloud Messaging is what I said, and I always, whenever I talk about messaging, I always like to begin with a story of what messaging used to be like. About 10 years ago, I was working in Wall Street as an enterprise architect, and there was one project that was given to my company to deliver for a major international bank. And this project was that they wanted to have instant messaging, chat-style messaging for all of their terminals. They had 30,000 terminals, and they wanted instant, direct messaging. Every terminal receives every message within a certain time frame, and on average, each terminal would issue about 100 messages a day. So can anybody do the math, say, for 30,000 terminals around the globe? How many messages would that be? It's a lot, right? So if you think about it, you have 30,000 terminals, each issuing 100 messages, and each receiving 100 messages from each of 29,999 other terminals. You're talking about, what was it? It was like 9 by 10 to the 9 number of messages floating around in this system every day. That's a lot of messages. That's a lot of scale. Now, of course, when we brought it to the customers who were saying that they wanted to build a system this way, we were saying you can't just flood your network with messages like that. You got to design your system in particular ways. You keep closely related messages close to each other. So take, for example, this customer had branches in Singapore, in London, and in New York. And we were saying, well, 99% of the messages in Singapore, the people in London don't care about them. And 99% of the messages in London, the people in Singapore don't care about them. So we started carefully designing the network for these messages so that you wouldn't completely flood your network with messages in order of 10 to the 9 every single day. And so we spent about 6 months designing what this thing would look like. And then we brought it back to the company, and we brought it to their ops people. And their ops people took one look at it and said, nope, not going to happen. Because even with all the design work that was put into this, the amount of infrastructure that would be necessary to be able to handle something like this was just obscenely expensive for them to build. It was way ahead of its time. It was pre-cloud, and the project got canned, and it ended up being replaced by a bulletin board system, which effectively gave them the same functionality where anybody could go and take a look at a bulletin board of the messages that have been posted by anybody else anywhere else in the world. And as a result, they got the same kind of functionality, but without that instantaneous communication. Now, when I look at something like Google Cloud Messaging, I'm not going to tell you that you can quickly and easily and cheaply scale to 10 to the 9 messages every day, but you don't have to think about all this back-end infrastructure. And that's what Google Cloud Messaging to me is all about. I like to look at it as a black box, and in that black box, I can send messages, and that black box routes messages to all of the clients that are registered for my application. It does it for free, it does it instantly, and it does it with lots of other types of functionality. I can go upstream messages, downstream messages, peer-to-peer messages, all that kind of stuff. And did I say it was free? It is actually free, and because it's cloud technology, it scales really nicely. So what we're going to do today is we're going to take a little bit of a look at what an application built on Google Cloud Messaging looks like in action, how it will perform, the type of performance that you're getting for free, the type of scalability that you're getting for free, and we'll take a look at what does it look like to build a simple application in Android that uses this, and then an app server that also uses this, built in PHP and MySQL, and hosted on a free web host. So as I mentioned, what is Google Cloud Messaging? Well, first of all, it's a hosted service. Google hosts this service on our infrastructure on your behalf. It manages the queuing and delivery of your messages. Your messages can be upstream, to servers and maybe stored in servers like a bulletin board style system that I mentioned. They can be downstream, which is much more interesting, where your users can receive instant notifications of messages in the system, or they can be peer-to-peer, right? So my people in Singapore and my people in New York in my earlier example could communicate with each other over something like Google Cloud Messaging. You can target single devices with messages, or you can target groups of devices with messages. And what I'm going to build a little bit later on, you'll see where I have two devices. Number one is the emulator on my machine, and number two is this phone beside me. And I'll show how I can target messages to either of those or to both of those at the same time. It supports topics. So again, thinking of my bank example, I could have a set of topics that are relevant for Singapore and a set of topics that are relevant for London, and people can subscribe to what they're interested in, and the infrastructure, this black box infrastructure, will handle the rest. And it's relatively easy to build. First of all, that back-end infrastructure nightmare is taken out of your hands, and while there's a few hoops you have to jump through in order to, for example, get things like an API key, we're working on making it easier and easier all the time to do that. All right, so what does it look like? So this is what a basic system will look like as we're building it. So the first thing is, remember I've been talking about GCM as a black box. So this GCM black box on the right is something that your apps will register with. And when they register with Google Cloud Messaging using an API key that you set up, you'll get a token back that identifies your app in the Google Cloud Messaging infrastructure. So that black box on the left is provided by Google. You build nothing. You call APIs on that. You get your registration tokens back from it. Step two then, in a server-based system like I'm talking about, is you build your own app server that then stores these registration tokens in order to identify the people who are using your app and in order to be able to send messages to the people who are using your app. And that's what I'm going to be building in PHP in just a moment. So your apps will then pass registration details that they have achieved from GCM to your server, where your server can store them. And you can store them with whatever identifiers you feel are appropriate for your customers, for your clients. Within an enterprise, that may be different than if you're working with the public. And then step three, if my slide will cooperate. There we go. So then step three is your app server, in this case, will tell Google Cloud Messaging what to send and to whom. It calls APIs in that black box, and it says, send this message to the person who's identified by this token, or send this message to everybody identified by this token, or send this message to this topic, and then people who subscribe to that topic will receive it. And then Google Cloud Messaging will deliver those messages on your behalf for you. Alrighty. So how do you build it? The first part of doing this is going to the the Google Developers Console and getting an API key and a sender ID. So your API key is what identifies you as it's a unique thing for you as a developer on the Google Cloud Console that will allow us to understand who's using it, how they're using it. There are no throttles, there are no rates or anything like that on the system. So it's not going to be used to say you can only have this many messages, but it just allows us to prevent people from being naughty by maybe having, trying to do a denial of service using Google Cloud Messaging or something along those lines. And then the sender ID is something that's unique to your application. So maybe you have multiple applications that you're building, and that sender ID would, like, in my banking scenario, you might have one message that's used by the buy side, one application that's used by the buy side and another one that's used by the sell side, and you have different sender IDs for these just so that you can separate them. There's two ways for doing this. You can go to Google Cloud Console and step through everything yourself, or there's this new thing that's only just come out in the last few days, and it's the URL at the bottom here. It's a quick start, developers.google.com/mobile/add, and there's a wizard on there that will you register your application, get your API key, get your sender key, turn on the APIs for you to use, and all that good stuff. Then step two is to build the Android application itself. So how do you build the Android application? Well, first of all, you need to use Google Play Services. Actually, who's familiar with Google Play Services? Okay, most of you, cool. So Google Play Services is it's a set of APIs that we ship that get updated roughly every 6 weeks, and it allows you to access a lot of Google backend services, things like location, maps, fit, et cetera, and Google Cloud Messaging APIs are shipped as part of that. Now, you need to set up some permissions in your Android application to allow Google Cloud Messaging to work. Typical things that you need to turn on, like internet access, that type of stuff. In your manifest, you're going to do two things. You're going to add a receiver and you're going to add a service. If this isn't clear, don't worry. I have code in a moment that shows it. I don't know if you're like me. I tend to think in code rather than in slideware, but I just want to list the things here. So you're going to need a receiver and you're going to need a service in your manifest. And then finally, you're going to need a class. In order to receive messages in your app, you're going to need a class that extends the GCM listener service. So earlier on, I had that black box sending messages down to your application. If your application extends GCM listener service and your application is registered with Google Cloud Messaging, then that's the part of your application that will receive those messages and know what to do with them. So what does this code look like? Okay, first of all, including Google Play services in your app is as simple as adding something to your Gradle file. Can anybody spot the mistake in this slide or spot something that's outdated in this slide? Yep. I'm using the plus rather than a particular version number, which is naughty, you're right. But there's one other. 8.1, thank you. I've actually put 7.8 in this slide for a very specific reason, and that is if you try doing 8.1 with the emulator right now, it doesn't actually work. So I downgraded my code to use Google Play Services 7.8 just so that I could use it in the emulator here. So well spotted, both of you. Now, secondly, is just defining the permissions that you need in your application in order to, for example, access the internet. The wake lock allows a message coming in to be received by your application so that it can generate a notification. And then this last one is, again, it's the receive permission for Google. I almost say Google Play Services. It's the receive permission for Google Cloud Messaging. Next up, you're going to define a receiver in your application, and it's pretty straightforward XML in your application like this. By the way, if anybody wants the source code for this app, I'm happy to share it. My contact details will be at the end of the presentation instead of trying to scribble down code off a slide. And then finally, you need the service, of course, for your applications. This service, you're just going to define it. You know, my application was called com.google.devrel.almaroni.gcmtalk, and I put a class in there called myGCMListener, and I just had to set that up as a service with an intent filter specifying that it's going to be received. And here's what the listener class would look like. So once we've set up all the metadata that we need, this is what a listener class would look like, something that would receive messages on your behalf. It's pretty straightforward. It extends the GCM listener service, and it overrides onMessage received. In onMessage received, you get two things. Number one, you get a string with the from, and that's the person that's sending you, and the ID of what's sending you the message. It's usually the server. And then you get a bundle with the data. And the bundle with the data is going to be a JSON message with a lot of details about the data. But the actual message that I'm sending through my server, the text message, gets prefixed with an M, and that's why I have here string message equals data.getString M. And then out of that, I'm just going to generate a notification. You can do whatever you like, of course, when you receive an incoming message. You can render it in one of your activities. But for this demo, I'm just generating a notification in the notification tray with the actual message. Okay, so let's take a look at what this would look like in Android Studio. Okay, well, that's what the application looks like with my beautiful design. I'm not known for my design skills. And okay. So first of all, I mentioned build.gradle. So here, if I go into my build.gradle on my app, you can just see I'm using com.google.android.gms play services. I started this application just by doing in Android Studio a file new empty activity application, and I've added a few things to it. Instead of going through all those steps and boring you here, I'm just going to show you the completed one. So here is where I've added play services 7.8. In my Android manifest, is this font too big, or can the people at the back read it? Because I know there's not a lot of code visible on the screen. I just made it nice and big. So again, in my Android manifest, I've set up the permissions that I want to use. So there's the user's permission. You can see the 3 entries here. Then there's the receiver that I want, and it's going to be a com Google Android GMS GCM GCM receiver. And then under my activity, you will see the service, and that's it. So the 3 things that I'd set up, the permissions, the receiver, and the service are all added to your Android manifest. Now, in my main activity, let me show you what my main activity would look like. It's pretty boring. So I just wanted to create a very simple one, a couple of text boxes, one where you enter your name, one where you enter your email, so it's hard to see on here, and then a button that you use to register this application with Google Cloud Messaging. So if I go to my main activity, and in my main activity, you'll see there's a text box for name, or an edit text field for name, there's an edit text field for the email, and then there's a button. On that button, what I'm going to do is register the application with Google Cloud Messaging. and that's done in here, where I'm just setting up, I'm doing it as a background task, which is why you see the asynchronous stuff there. And on Google Cloud Messaging, this number here was the sender ID that I spoke about earlier on. So I get my API key, which is associated with my Google account, and I get a sender ID, which is associated with my application. So this is the sender ID for this specific application. And I just get that back as a reg ID. And then the rest of it, that's the only thing that I'm doing to register with Google Cloud Messaging. And then the rest of this is now posting to my backend server. You can see here on the client.post, I just went to one of these free web hosting companies that will give you PHP and MySQL, and they gave me this URL, gcmtalk.site40.net. I put a PHP file on there, which I'll be showing in a few moments, and I'm just posting the name that the user has entered, the email that the user has entered, and the registration ID that the user has entered. Oh, sorry, the registration ID that the user's gotten back from GCM, and then I'm posting that up to my server. So my server will get that registration ID, so then whenever I want to try and send messages to any of my clients, it has that registration ID, and it will send it down to the client that I'm executing here. Clear? Okay, I see now. If I'm going too fast or if there's anything confusing, just feel free to interrupt. We're all very informal here. Just yell out if you have any questions. And that's pretty much it for registering my application with Google Cloud Messaging in order for my server to be able to send messages via Google Cloud Messaging to my application. And then a quick look at the listener. Let's see. Earlier I mentioned, and I showed it on the slide, it's just something that extends GCM listener service, and then I override the onMessageReceives method in that. And there I'm getting my from and getting my bundle of data. I'm taking a message out of that as a string, and I'm sending a notification. And then this code here, if you've ever built a notification in Android, will look very familiar. I'm just using a notification compat.builder. This send notification has nothing to do with Google Cloud Messaging. This is just taking that string that was received from the Google Cloud Messaging server and turning it into a notification. It's straightforward. It's pretty standard code. All right, so when I run this, I will get something that looks like this. All right, so it's the two text fields that I mentioned that I'm going to enter. I can put whatever I want in there. And I read, and it was a name and an email, so I'm just saying my name is phone demo name. The email was hello@room, and there was a register button. Now, I had done this earlier, so I will show you what the server looks like. So, who's familiar with PHP here, first of all? Okay, and then you've probably heard of a tool called MyPHPAdmin. All right, so MyPHPAdmin is a tool that's a web-based tool that allows you to inspect and play with a MySQL backend database. So I know the font is really small here in my browser, but what I had done here was earlier, just while you guys were in the keynote, I ran this application in the emulator, I ran this application on my phone, and I hit that register button in order to generate a token and register it. And as a result, I got these two records in my database. And you can see the GCM reg ID is that long string is the actual token, and that's the unique identifier for the device that's running the cloud messaging. For the device that's running the app that will consume the cloud messaging. But what I'm going to do now, just to show that this is real, is I'm going to delete them. So I'll come in here, and in PHPAdmin I can delete them. And that'll take a moment. All right, so now I have nothing registered. And if I go back to my site, and I'll talk about how to build a site like this in a moment, we should see after a refresh, okay, there are no devices registered yet. So now if I come into my emulator, and I'll just say hello@room again, something like that, so we see it's something different. I'll hit register. It's a really poorly designed application. I don't have a spinning status or anything like that on the register, so it'll take a moment to register. I'll come back and I'll refresh the site, and we should see in a moment. Like I said, this is a free public site. Hopefully my Wi-Fi is working. And he hasn't registered. I'll try and rerun it again in a moment. Just let that refresh. Everybody's hitting Wi-Fi at the same time, so it's still waiting. Nope. Okay. Isn't it always like that when you try to run a demo live on stage that it never works? You run it beforehand I ran it beforehand while all you guys were in the keynote, and it worked great, and I run it now and it's like, no. So that's another try. So I'll call it that. And phone at home.com, something like that. Let me register. And refresh. Pray to the demo gods. Pray to the Wi-Fi gods, and nothing's happening. I'll come back to that in a moment. Alrighty. So we can talk a little bit about the app server, and then I'll see if the demo's behaving after that. So earlier we saw, this was how I built the Android app, which isn't working right now. But how I built the Android app was just very straightforward. It was a single activity. There were a couple of text fields. There was a register button on that. When I registered, I called GCM's black box in order to get that registration token back. I had a couple of them, which I deleted before the demo failed. And those registration tokens would then be captured by my backend server and stored by my backend server, and then used by my backend server if I want to talk to individual devices, or I could take all of them if I want to talk to all of my devices. So how do we build an app server? What does this thing look like? Well, first of all, there's a database in it, and I gave a sneak peek of that a moment ago when I was using the MyPHP admin. So in this case, a very simple MySQL backend database. It's storing the registration tokens, and it's storing just the name and ID that I had. I have a UI for sending messages. You saw that basic UI. It's just a simple HTML UI. And then there's the interface to Google Cloud Messaging itself that requests the messages to be routed either to one device or multiple devices based on those registration IDs that had come out of the devices. And this is like pretty much what it would look like. And this application that I was showing a moment ago would look like this. So my Android would call register.php, pass it the three things: the name, the email address, and the registration token. And register.php would then just store them in the database. Then the user interface for this, what I was using in my browser, I'm just calling index.php. And what index.php was doing was do a query of everybody in the database, get their registration tokens, and just generate that UI that will allow me to send to individual ones, or will allow me to send them all in one shot. And then the main part was the GCM send.php. And this file, what it does is just using curl to talk to the Google Cloud Messaging backend, picking the IDs that it wants to, based on the tokens that it wants to send the messages to, sticking them into headers, taking the string of the message, passing that to Google Cloud Messaging, and then fire and forget. It's done. At that point, the messages would be routed back to my various devices. So here's a quick example of this is what the registration would look like. So if you've ever seen PHP, this is PHP 001, right? I'm taking a look at the post for the name, I'm taking a look at the post for the email, and I'm taking a look at the post for the register ID. I'm taking them and I'm using just a MySQL query to store them in the database. I have a couple of things here that are DB functions, and which is just a class that wraps the MySQL, what do they call the MySQL admin stuff, so that I can actually just call DB store user and pass those parameters to it, and an insert query will be generated for me that will push them into the database. Sending messages with curl, this is how easy it is. First of all, the URL is android.googleapis.com/gcm/send. On that, I pass a couple of headers. The first of these is my API key. If you remember way back at the beginning, I was saying you use the Google Developers Console with the wizard that was at that URL, and that will give you the sender ID and your API key. This is your API key. You put it in the authorization header. And the content type that I'm going to post to this is JSON. That also goes in the header. And then finally, how I send the data to it. I have a string that I call data, which you can see here towards the bottom. So I have a data field, and I put that string into that. And then I have an array of registration IDs. So if I'm picking one registration ID, one based on its token to send to just to target one device, I'd put one in there. If I want to send it to everybody, I'd just send it to everybody in there. And then I just curl it out. So there's set the headers, set the URL, tell it that I'm posting it, encoding in JSON, and then call curl exec to actually just do the curl and send the message. So very, very straightforward, very much 101 type PHP. And it's just about getting those registration IDs. And if you know what those registration IDs are that you want to send to, and GCM provides them for you, you stick them into the array, you encode it in JSON, and then you curl exec that. Alrighty, so let's look at the code for the app server, and then I'll come back and try and get the demo to work. Oops. My power saver kicked in. Anybody familiar with Coda? Anybody use Coda? It's a great editor, I love it. So I'm just showing the code here in Coda. Let me see if I can make the font a little bigger. Let's do. All right, does that look clearer? All right, cool. So again, the files that I have in this, if I just take a look at a few of them. So first of all, for registering, I got caught on my scroll bar there a little bit. Let me see if I can get rid of that corruption. No, weird. Okay, so again, for registering, PHP 101. I'm taking a look at the post, I'm pulling in the data from the post, and then I'm storing the user in the database using these database functions that I'd created. And we can see what they look like. You know, to store a user, I'm sure you're all familiar with an insert query. Okay, I'm not doing any kind of sensible programming here by doing a parameter validation or anything like that. I'm sure you could issue a denial of service attack on this because I'm not, you know, filtering my parameters. But you know, you'll forgive me for that hopefully because this is just a rough demo. But again, it's a MySQL query. I'm inserting into this GCM users table the name, the email, and the registration ID for that user. And then if I ever want to get them back, it's just the same kind of thing, a MySQL query to get them out. The user interface for the app itself is index.php. And if I come down to the index.php for a second, and you'll just see I'm querying that database. So yeah, I'm just querying my database. I have a db.getAllUsers. And then I'm going to loop through and just generate HTML forms, one for each user, and then one for all of these users. And then those HTML forms, as we can see here, they're going to, when I submit them, they're just going to call the send PHP that I spoke about earlier on, where I put the message into it, and I put the list of all the registration IDs that I want to have in there in it. And if I go back to my browser for a second, what that looks like was this one. So let's see if that user got registered yet. No. Oh, there it is. Okay, so it finally came up. So that when I was running on my emulator, you see now this box that appeared was for that user. I'll rerun it on my phone in a moment so we can see what it would look like. But now I have one user in the database, so I have one GCM token in the database, which is for this user. And if I type a message in here, say like hello room, and send it, hopefully it'll show up in the emulator. There it goes. And you see the notification just appeared in the emulator. And when I drag it down, we can see that GCM message, hello room. So if anybody wants to send a message to me, keep it clean. You know, you can actually see the URL there. This is running live. This app server is running live on the internet. And like right now, I also have here just say, you know, please keep it clean on this one. And this is just to send to all registered devices. And I don't know if you can actually hear it. And there's the message actually appearing. And you can see how quick that was as soon as I had typed it. And that's going to my emulator. Right, so the emulator's receiving that message from GCM and actually rendering it in there. Okay. So, any questions on the PHP part? Is it clear? Clear as mud? All right. So that's what a very, very simple app server would look like. There's several things that it needs to do. First of all, you need to I heard the sounds. Did somebody just send something? I just heard the sound of a notification. Yep, we got a smiley face up there. So there's several things that it needs to do. So first of all, when your Android application has, I need to turn off my sound. Messages are all popping in now, and it's like, so when your Android application registers with Google Cloud Messaging, you will get a token. You need to, Google Cloud Messaging doesn't have any intelligence about sending the messages for you. It's just a black box. And you call that black box and tell it to send messages to devices on your behalf. That token is the identifier for it. So on your app server, you need to store that token. Now, there's a million different ways you could have done it. I just decided to use this free public PHP server to do it. stored the token in a MySQL database. You could add a lot more intelligence to that. You could have, for example, people from Singapore have a column in the database to identify they're from Singapore and people from London. If you came in late, I was talking about an example of an application that ran in Singapore, New York, and London. That's why I'm picking those two. And it's up to you how you would build it. It's up to you how you would design it. It's up to you how you would filter out your messages and how you would have users work in peer groups or whatever. But don't forget there's also the concept of topics in Google Cloud Messaging, which I'll talk about in a moment. But that's the most important thing, is that your application server needs to be able to send the messages, or needs to be able to tell Google Cloud Messaging to send the messages, and as a result, you need to track the user's tokens. So my demonstration there was just to take them and stick them into a MySQL PHP. And then your application server, the other thing that it has to do is then just simply call the Google Cloud Messaging APIs, pass it. If you're using the HTTP post methodology, you pass it a JSON encoded string that has the list of the registration IDs plus the message that you want to send, and then it handles the rest, and it does it pretty quickly, as you saw. Is it safe to look at the other messages you guys have sent? How does this work on iOS? Oh, that's a great idea. We should actually have this as the way for doing questions. It does work on iOS. We don't have Google Play services, but there are a set of GCM libraries for iOS. I don't know that much about them, to be honest, but GCM works across. We have a web client for it, so you can actually send messages to HTML, JavaScript-based sites. There is an iOS client for it. There are a number of libraries that you can use in iOS. They're not in Google Play services. And then, of course, on Android, there's Google Play services. Another question over here? I'm sorry. Right. Oh, that's a lot of good questions there. So first of all, it's like, it's not always on. It's on when your application is running, if your application is built for using GCM. That wake lock permission that I spoke about earlier on is the key to it. So the idea behind that is that that's what, you're giving your app permission to wake the phone upon an incoming message. I don't know the specifics about how much battery it's using, but one of the things is that we've actually built this to optimize for battery use in these connected messaging scenarios. So you're always listening for messages, but it's extremely low battery usage. I don't have the stats on how much it is, but that's one of the core tenets of how we've actually built it, was to keep the battery usage as low as possible. Just to repeat the question, sorry for the folks who didn't hear it, it was, if Google Cloud Messaging, if an app built using it is always connected in order to listen to messages, what's the impact going to be on the battery, and is there any way to turn it off, right? Right, so you can build your app to sniff for when a connection fails, and then you would generate a notification to your user if that happened, so yes. And if you are actually disconnected for a period of time, like you go off the grid, when you come back on the grid, GCM actually has your messages for you and will resend them to you. The messages don't get lost. Yes. Something like that, yeah. Alrighty. So just moving on. So step 4 is just enjoy the awesomeness, as I like to call it. So as you saw there, I ran it in the emulator. I can also run it on my phone. It's registering and sending messages to any or all devices. It's totally free of charge. We don't charge anything. And answering your question from earlier, there's a guaranteed message delivery so that if you do get disconnected, the messages will actually be resent for you. Next steps, upstream messages are also possible. So, in this case, I had a server that I had built that was sending a message down to my device, but I could also send from my device up to the server and have that route my message to other devices. So I could have I can either have upstream messages for something like a bulletin board, or upstream messages to have them routed, so I can do a peer-to-peer type thing. There's topics, so that you don't get flooded with too many messages. You can actually subscribe or send to particular topics. So again, using my scenario of the bank that I was talking about with Singapore, London, and New York branches, the buy side and the sell side in each of these could have a topic. And as a result, not everybody reads every message. If I'm only interested in the buy side in Singapore, then I could just receive messages for the buy side in Singapore, that type of thing. Priorities, there are messages priorities too, so that you can set different levels of priority of a message. That's something that's actually evolving in Google Play Services, so watch out for, we have some new stuff coming in Google Play Services very, very soon, and there's some changes in priorities there. But just in managing priorities, so you can have like high-level messages and low-level messages, so that if you've built an application that, for example, receives messages as notifications, like the one that I built here, so that you don't keep getting pinged by notifications, you can change priority of messages. Maybe some generate a notification, maybe some get routed to an intent for later viewing. To learn more, we have this site. It's developers.google.com/cloud-messaging/GCM. There's also this new thing. I think it has been released by now. If not, it's releasing imminently, called the GCM Playground. The guys told me I could talk about it today, so it's all right. So it's, if you go to github.com/Google Samples, the GCM Playground, and they have a similar type of application to what I've built here, except they built it in Go because they thought Go was much nicer than PHP. No flame wars, please. And there's also some great dev bites out there. So dev bites, if you're familiar with Google developers, these short videos that we produce, 3 to 5 minutes long, just talking about a technology. And there's one great one here from my colleague Yarek. I don't know why they put the About the Speaker slide at the end of the deck. I don't know. That was the template. So about the speaker, that's I've mentioned, I'm a developer advocate at Google. I've authored like about 20 programming books, and I've changed into writing children's novels now. This is my latest one. It's the cover reveal was just yesterday, so I was so happy that I was able to put it into my slides, and it's coming out next month. And I'm the host at Google of a show called Coffee with the Googler. Anybody watch it? Yeah, thank you. And by the way, if you have any requests for people for me to talk to at Coffee with the Googler, please let me know. And contact details, so on Twitter, I'm at @lmaroney, on Plus, I'm plus Lawrence Maroney, and facebook.com, lawrence.maroney. And if you want to email me, it's the same, lmaroney@google.com. And so we have a few minutes if anybody has any questions.
I know in the past there were some kind of gotchas around token invalidation.
Around what, sorry?
Token invalidation.
Okay.
Do we need to register any receivers or check to see if the GCM token that we have has been invalidated?
So the question for everybody else was that in the past there have been issues around token invalidations. So do we need to, double check our tokens to see? I'm not familiar with any token invalidation problems, first of all, but I would argue that it's always a good idea to double check. And so we have this new Instance ID API, which is part of Google Cloud Messaging, and I believe you can use that to check your tokens. So maybe, every few days or something like that of running an application, excuse me, that you could just do a recheck and validate your token. It would be a good idea. So over here again. Is there a round-trip facility where a server can receive? I'm sorry, it's hard to.
I seem to remember that there was a round-trip method where you could send a response in time.
Yep.
Is that faster than the streaming HTTP? Is it going to be better to exploit the already open TCP connection to the server with that faster than just making the HTTP connection back on server?
Good question. I've never tried it, so I don't know. I'm only going to guess. My guess would be no, that it would be better to send them up through the regular channel, so that way you get the guaranteed delivery. If you have that open connection, I have no idea what's on the other end and how it would respond to it. I would always just recommend, go through door number 1. But I don't know for sure. Over here. Okay, so the question is, when I got the registration token for a device, is it device specific? I have a funny story about that question, because I knew somebody was going to ask it today. So I decided to go and look up the code that I had used in my demo to just check that for sure. And it turned out I was using deprecated code. And so it's like, then it was like 20 minutes before my talk. And so it's like we made a note upstairs that was saying before you do a talk, make sure you don't do deprecated code. So anyway, but to answer your question, if you're using the Instance ID APIs, you can have a single registration token across multiple devices so that if you receive a notification on one of your devices, you want to receive it on all of them, right? Rather than it being routed to multiple ones as them being identified differently. It can be. So if you can have it so that you have a registration token that's unique per device, or you can have a registration token that's shared across ones based on your Google ID. All right. In the back here. What communications protocol does GCM use? So when you're coming downstream from GCM to the server, I actually don't know. I've never looked at it. If I'm going upstream from my app server to GCM, it's just an HTTP post. Right. Yep. So if you've built an application for Android TV, how do you receive the notification? I believe it's just the same. It's you extend the same class. The service is not available. Can I get your details and I'll check in on that one? I've never tried it, so I don't really know. Okay, time for maybe 2 more questions at the front here. What are the what, sorry? Payload size for messages. Oh boy. It's on the site. What was it? 256 kilobytes. Okay, thank you. All right, well, thank you everybody, and enjoy the rest of your Android barbecue. Thanks.